Okay, thank you everybody for joining the Murray Amateur Radio Club. It is May 1st, 2025, and we are excited to have everybody here. We are going to be talking about repeaters tonight, and let's see, I'm trying to get there we go. So, as you can see on the first slide, repeaters. I apologize for being redundant, but we are talking about repeaters, right? So, yeah, Pete and repeat. So I'm trying my laptop is being a little interesting. Let's try that. Okay, very good. So, as you know, we started the Back to Basics program where we are talking in real simple terms on this first week. So this is a continuation of the Back to Basics series. The goal, of course, is to activate new hams and to reactivate hams that haven't been here for a while. This is designed for non-technical people. We want everybody to have fun with amateur radio, and it starts by understanding their amateur radio, right? Now, this is something that we ask every class. If you're interested in teaching a class, let me know. If there's a particular subject that you want to know about, that you're interested in, let us know. And if there's something that you don't understand during this presentation, what are you going to do? Ask, okay? There is no such thing as a dumb question, and I never, ever want to hear, I'm sorry that I'm asking you another question, okay? If the entire time we talk about one thing and it's just answering questions, then that's time well spent, okay? So, does everybody have the rules in hand? Okay, very good. So, yeah. Well, there's always one in the room, but that's okay. Okay. So, let's talk about repeaters. So, the basic definition and this definition is a definition that happens to talk about most repeaters, okay? A repeater is simply a system of electronic equipment that receives a signal on one frequency, and what does he do? He repeats the signal on another frequency, hence the word repeater. Okay, it's not that difficult. As a matter of fact, if we have a lot of repeaters here in the Valley. There's a lot of repeaters out in the U.S. in general, so you can go ahead and do a repeater lookup. And we're going to see some clues in the repeater documentation that's out there on the web. In particular, when we do a search for the repeaters, all the listings are displayed relative to the receiving radio, okay? So the displays that we're going to be looking at, the web pages, have to do with what you're going to be doing on your receive side, not on the repeater side. This is for you, right? And so it doesn't matter if you're a mobile HT or a base station, it's all the same. As a matter of fact, here's an example, and I do need to get my laser pen ready. Okay.
Can I ask a dumb question?
Okay, now you've just violated the first rule. Okay, go ahead.
See if I can think of a way, try to make it sound intelligent, even though it's kind of dumb. I've heard that there are repeaters that transmit and receive on the same frequency. Is that
That's correct? We're going to talk about that.
Oh, good. Okay.
Yep. So that's why I said this definition is for, generally speaking, the majority of repeaters. Okay, there's, like we know with rules, there's exceptions to everything, right? So, in the Utah VHF Society's webpage, you do a search for Utah repeaters, and And here's what you see. As a matter of fact, if you do go down to the 1.25 meter repeater list, this is a concatenated version of that, but you can see the Murray repeater, 22396 with a little minus sign there, and we're along the Wasatch Front, and there's our call sign, N7MRY, sponsored by Mark, and there's the CTCSS. So generally speaking, every repeater lookup website will give you everything that you need to know to program into your radio so that you can talk to the repeater. Here's another example. Here's one that this has nothing to do with VHF Society. This is like the repeater book on, if you Google it. And I did a search for repeaters near me, 1.25 meter repeaters near me. And there's the Murray repeater. So you can see the frequency, and you can see it only displays one frequency, okay? But I think you may or may not know repeaters use two frequencies, right? So we're going to talk about that second frequency. As a matter of fact, it gives you a clue on what that second frequency is, and that's this offset value here. On the 1.25 band, it is, in Utah, it is a standard to have a negative 1.6 megahertz offset. Now we're going to talk about that, so don't worry about it. And then there's this tone. It's not tone up or tone down. That's a separate column. Tone shows 103.5. There's the location, call sign, and if it's an open repeater for normal use for anybody. And so here's an example here. We, just by looking at this web page, we know what the frequency is, and this frequency is always the receive frequency of the radio that you're going to be using, okay? Whether it's an HT or a mobile. So that's the receive frequency. And since there's an offset of minus 1.6, well, what you do is you just subtract 1.6 from the frequency, and it gives you another frequency. That is the transmit frequency to your radio. So some radios can do an automatic repeater shift, or repeater shift, and so you don't have to worry about that. Chinese radios like Baofeng's, you have to actually program in the transmit frequency. There is no automatic repeater shift on those radios. But it's easy to do because you have all the clues right here. So there's the receive frequency, 223.96. The transmit frequency is 222.36, and the tone is 103.5. So we have successfully cracked the key of programming our radio for this particular repeater, and we're gonna talk about each of these in more detail. So here is a diagram of person A over here. He wants to talk to person B over here, or over here, person C. And unless you have a really powerful radio, most radio communications can't go through the mountain, right? If that radio could go through the mountain, you would not want to be standing near it. You would fry instantly, right? So because we can't go through things, we are going to go around things, and that's what this repeater is doing here. So all of the examples that I show here is based on the Murray repeater, okay? But it doesn't matter what repeater we're talking about, we're going to do the same thing. So in relation to the HT, this HT here, your radio in your car, at your home, whatever, in relation to that, the transmit frequency, we already figured it out at 222.36, and the receive frequency is 223.96. That's on the user radio side. On the repeater side, it's just the opposite. The repeater receive is 222.36, and the repeater transmit is 223.96. So when we look at our radio, we're looking at the frequency 223.96, right? That is the receive frequency. That is the frequency that the repeater is transmitting on. Okay? So whatever we talk about on the, in this case, in HT side, it's just the opposite for the actual repeater. So the receive frequency is what is shown on your radio, and the transmit frequency is whatever the receive frequency is, plus or minus the offset frequency. There's that, the magic coded method of finding out what the transmit is. So for Murray, the repeater listening, the repeater is listening on 222.36. So our Radio Shack, our repeater, is listening from your radio on frequency 222.36. And not only that, but he's also listening for a subaudible tone of 103.5 hertz. So during the nets and during all the communication that we do, we always include the PL tone, right? Because that's also required. And we're going to talk about why that is so important. The repeater then repeats the same signal that he receives on 222.36 and retransmits it with no subaudible tone. Okay, and we're going to learn that you can configure repeaters to also transmit a tone, and it doesn't have to be the same tone. It can be a receive tone of 103.5, which is our transmit tone. When we program our radio, we are programming the transmit, the CTCSS, the transmit CTCSS, which is the repeater's receive PL tone, right? CTCSS. We could have just as easily programmed the repeater to also transmit a tone so that you would have to have your receive tone configured in the radio for the squelch to open up. Okay, we don't do that. We leave it open. So the only thing that's required is the transmit from the HT, in this case, to the repeater with a tone of 103.5. If the repeater hears some RF on that 222.36 with no subaudible tone, what will the repeater do? He stays quiet, doesn't he? He does not repeat. The transmit radio is quiet. So that kind of gives you a clue as to what we're going to be talking about later on. So let's have an example here. This radio here is going to transmit. So he's transmitting, and the HT is transmitting on 222.36. Okay, well, the repeater is listening on 222.36, and if he's transmitting the 103.5, then he will go ahead and retransmit that on a different frequency. The HT receive is set to 223.96, and that is the frequency of the repeater's transmit. Okay, so the repeater's transmitting on 223.96, which is our receive. Okay, the HT's receive, and there's no PL tone involved here. Any questions on this very basic communication event that happened? The HT sending FARs out into the Never Never Land. The repeater is hearing that. He hears it on the proper frequency. He hears the tone. The repeater then knows to transmit that same signal out into the FARs, and people receive it. If they're on the right receive frequency, right? So here's the question. How can a radio receive and transmit at the same time? This is how can a radio do that? It can't. So let's talk about that, okay? And you are correct. We're going to find
That's
out.
what's so great about a radio or talking to people, because you can't get interrupted.
That's right. When you're talking, when you're the one talking. Yep. Okay, so let's find out why a repeater can transmit and receive at the same time. So, again, the definition that we learned on the first slide is it's a system of electronic equipment. So let's see what that electronic equipment is. First, you have a receiver, which is a radio. Then you have a transmitter, which is another radio. So there's the answer right there. You also have a duplexer, sometimes called canisters, sometimes called cavities. Then you also have an antenna, and that antenna could be one antenna or two antennas. Some repeaters have antennas for the separate transmit and receive. Some repeaters have a single antenna that does transmit and receive at the same time. That is black magic, but it works. And then you have supporting items. So you have the antenna mast, you have the heliacs, you have connectors, you have everything that supports the first four. So that is the system of electronic equipment, and some not so electronic, like the actual coax and the mast. So let's take a look at Mark's repeater. And I've broken out what each of the repeater pieces looks like. So as you can see, this box entails the entire repeater system, okay? So it's these canisters. We have 4 canisters. These are the duplexers, and we're going to talk about that. And then this box right here refers to the controller, the 2 radios, the power supply, and there's some other things in there. So this is what Murray's repeater looks like. Again, we are using a single antenna. We're using a single heliax that goes up to the antenna. And so to me, that's amazing, because this receiver is receiving and this transmitter is transmitting all at the same time. There's like a few millisecond delay for the actual transfer to happen, but it's too quick, you can't hear it. But the point is, both of those radios go into these duplexers, and it's the magic of the duplexers that allows us to use a single antenna with 2 radios hooked to it, operating at the same time. To me, that just blows my mind. It's amazing how that does it. So those canisters do a lot of things. One of the things that they do is, well, sometimes repeaters are on mountaintops, especially if you live in Utah, or high buildings or towers, and sometimes you have a whole bunch of repeaters in the same area. Can you imagine all the RFs that are floating around in here? And it becomes quite busy. Well, as a ham radio operator, I don't care what the FBI repeater is doing. Well, maybe I do. But really, I don't. It's not causing, I don't want to know, right? Maybe it's better not to know. But there's all kinds of RFRs floating around. And so we want to filter out everything that does not have those 2 frequencies that we are dealing with, okay? And so we use these duplexers to help with that. We have 2 sets of canisters. They're doubled. There's a receive pair and a transmit pair, okay? The transmit, and they both do the same thing except in opposite forms, right? They are a band pass and a band reject, and both of them are the same thing. It is a single canister is a band pass slash band reject. The whole idea with duplexers is to keep the frequencies that are lower than the target frequency and the frequencies that are higher than the target frequency off the line, if you will. It filters that out. So it doesn't matter if there's 127 megahertz signal coming in, because that antenna can hear every frequency that's coming through. Now, as we know with antennas, if you get an antenna that's cut to be resonant, then it receives that a lot better, right? But even if the antenna isn't resonant, those little FARs sneak into the radio, and the radio has to have the ability to reject all of that stuff. So that's what these duplexers do. They reject. Plus, you have to take into account the bandwidth of any communication. So we're FM, right? All the UHF and VHF stuff that we work on are all FM. We don't use AM. And so there's a bandwidth that also gets passed through there. So you have 222.360 as the radios transmit, which is the repeaters receive. So this is the 222.36 that he is filtering out everything except 222.36. He can't hear the 800 megahertz. He can't hear anything. He's only passing what the radio wants to hear. Okay, so that's what the duplexers do at a high level. Any questions on the duplexers? Okay.
Physically, how are they made? I know they're filters, I understand electronic filtering circuits, but that physically, what's inside the can?
These cans are actually quarter wave antennas. Okay, so we have 4 of them there. We have an entire wavelength of our repeater frequency, and most of it is hollow. You can see, we can only see 2 here, but if you look back here, you see these little knobs up here. You can see that there's 4 knobs. Each controller, if you will, is tied to a single canister. So you see 4, so that means we have 4 canisters, and that is how you tune these. So once you get it tuned on the bench and you install it, you put a spectrum analyzer on there and you tweak it to the frequency that you want to let through, okay? And most of it, again, is airspace. It's how it resonates on the inside. It's
similar to some of the old antennas that had a ferrite core in them, and you adjust that to tune the antenna?
Yeah.
Okay.
I would suspect it's real similar to that. There's some differences, but in this class, we don't need to know about, okay?
That's my curiosity for
Yes. So, the whole idea is we don't want to hear all this stuff. The radio doesn't want to hear all that stuff. He just is looking for a clean signal that he's expecting, right? He was programmed with. So that's what these canisters do. Now, let's take a look at the Mark 220 antenna. You can see it's a single antenna. It is tied, there's like an 8-foot LMR 400, and then it's 7/8 inch heliax all the way down right into the lightning arrestor. So we are 7/8 all the way into the shack. What does that mean? Well, that means, first of all, it was very expensive. But the reason why is you can run a signal for a long distance and have extremely little loss, okay? As a matter of fact, our transmitter radio is only a 40-watt radio, okay? It's not 100 watt, it's not 200 watt, it's only 40 watts, okay? And as a matter of fact, that's been tweaked down to 35 watts. And the reason why it works so well is, well, let me give you a number here. So the transmitter wattage that's coming, the number of FARs that are coming up that heliax is only 40 watts or 35 watts. But because the antenna is a high gain antenna, which means it has like a 7.8 dB gain on it, and the height, we are at 180 feet above the ground. The effective radiated power is 340 watts. So it's as if we are on a 340 watt transceiver, and this is why it works so well, okay? I think it would be cool to have a little red light up there, yeah. Okay. Now,
One on each one.
there's actually 3 lightning rods up there. No, we need 3 of them. Anyway, so, squirrel. So the duplexers allow our antenna to listen and talk at the same time, okay? Now, here's a scenario where we have 2 antennas for a single repeater. This is the Murray power repeater, and they have a transmit antenna and a receive antenna. But if you look in the shack, you will see that there's also some small canisters. They also have duplexers. And so the question is usually asked, well, Dan, you just said that if you're running a single antenna, you need duplexers. Well, these people are doing 2 separate antennas. Why do you need a duplexer? Well, these antennas are really close together. And if you didn't have the duplexers to do the same thing that it's doing with the with our single antenna, you would overblow the front end and do all kinds of fun stuff, right? So, yeah, so they have to have canisters as well, even though they have separate antennas. Now, you can get away with that by putting one of these antennas, 300 meters away, okay? But then that is a whole other logistical nightmare with coax and all that type of stuff, right? So this is the easiest way to do it. Any questions? Go ahead.
Yeah, intelligently phrased dumb question. I guess I would ask the reverse. If they have a duplexer, why do they have 2 antennas then? Why not just 1 antenna?
Right. Because the salesman sold them 2 antennas. I don't know.
Well, it's not a company, it's probably their meters are on one and their mobile operations is on the other.
That's a good guess, but that's not what's happening. If you go into the shack, you see the separate transmit and receive into the same repeater. So they are, and they go into the canisters. Why? I don't know. And it turns out I don't have to care. I just have to worry about my antenna. Yes, Justin?
Their duplexer's not really a duplexer then, right? Just one antenna goes through one and the other antenna goes through the other, and they're not actually linked together?
Well, they're not linked together, but they're linked together at the duplexers. There's a set of duplexers that go into the transmit antenna, and there's a set of duplexers that go into the receive antenna.
When you say a set of duplexers, a duplexer means the transmit and receive are on the same physical wire. Is that actually...
They're not on the same physical wire.
So it's not really a duplexer, it's just one totally separate filter for the transmit.
It's a band pass filter, let's put it that way.
Okay, that's what I was wondering.
Yeah. So...
Okay, interesting.
Yeah. So hopefully this diagram looks a little bit, kind of understand a little bit more what's going on. Now, again, we have a single electrical connection coming from the antenna into the lightning arrestor. Now, who can tell me how a lightning arrestor works, and why doesn't it mess up our communications? What's the purpose of a lightning arrestor?
To arrest the lightning.
Arrest lightning. Yes, I knew that answer was coming.
To defer the lightning to someplace else.
Okay, so when a lightning bolt hits, we want to direct that lightning to a safe location, right? We want to take it to ground, right? So on all these lightning arresters, we have these gas tubes, if you will. And that's the thing that, now people online can't see this. Oh, maybe you can. Is my camera on? May not be on. I just turned it on. Okay. So in the lightning arrestor, you have the line, the center conductor, and then you have another conductor that is tied to ground. When a lightning bolt hits, this arcs and it goes to ground. Okay. It's easier if I drew it on the board, but no one can see it, so just have to trust me. Those gas little nodules can be replaced, okay? Now, these aren't for direct lightning strikes, okay? They're for near misses, because 2 million volts on an antenna coax, the antenna is going to lose every time, okay? So it helps prevent that.
That's what the top lightning spikes are for, is to take the lightning hit and direct it directly to ground before it hits.
Well, let's talk about that. I think that's a good thing that we brought that up. So let me go back to our repeater there. We have lightning rods up on top that are tied to the tower. Our antenna is DC grounded, okay? Which means the entire antenna system is tied to the tower. The heliax at the very top, I don't know if you've seen heliax before, but if you tear out the outer PVC material, you see this copper corrugated entity, right? It looks like a coax, but it's made out of thick copper. And then you have a dielectric, some type of foam, and then you have actually another hollow tube. What does electrons ride on in a wire? Does it ride on the inside of the wire or the outside? It rides on the outside of the wire. So that's why you don't need a solid center conductor, you just need a hollow one, because that's all the RFs are on the outside. Okay, so you look at the big old AM broadcasting stations with 200 gigawatts of power shooting out, they have these massive, the center conductor is like this, really thick, and it's hollow, because the electrons never hit the inside. Okay, so at the very top, they've stripped away the heliax sheathing and tied that copper corrugated braid, if you will. On regular coax, it's braid. On heliax, it's solid. That's why they call it hard line, right? And that is tied, that is bonded to the tower. That same bond happens at the base of the tower and before it goes into the shack. So everything is bonded together. So what does that do? It's amazing. There's two ways of thinking about it. It creates kind of this bubble around the mast where when lightning starts happening in the area, lightning really doesn't see the tower. And what really is happening is we are bringing the potential to the top of the tower. So the lightning does not see a large, tall item. All he sees is ground. he is more likely to hit something that isn't grounded, that is higher than the tower. So we could have a shop right next door that's not grounded. Lightning will slam that before it hits our tower, even though we're 200 feet higher than the shop next door. And that is because how it's grounded. Now, it turns out Mother Nature makes her own rules sometimes, so we hope that that happens all the time. But that's why everything is bonded together. Bonding is a good thing. Okay, any questions on our repeater system? And for that matter, any repeater system with the same configuration. Okay, so here we have a diagram again as to what's going on. We have the radio transmitting on the 22236. The repeater is listening on 22236. The repeater is listening for the 103.5 hertz on getting to the PL tone. And if he hears that, then he'll transmit that. And again, it only takes a few milliseconds for that process to happen. And he retransmits at 223.96, which is the frequency of our radios. Any questions? We could stop right there, and I think we talked about everything. But yet, there's more to talk about. So, in order to use repeaters, there's two things that you have to know, okay? And we've discussed this already. One, we need to know the frequency offset. Why? Well, because we're transmitting and receiving on different frequencies, right? So that is critical. We also know the PL tone. The PL tone is an optional thing. It does not have to be implemented, okay? The repeaters, there are some repeaters, as a matter of fact, that don't require a PL tone. You just talk into it and it'll transmit anything that you feed it, okay? So let's talk about the frequency offset. For the 2 meter band, it's 600 kilohertz, okay? Plus or minus, depending on where on the band you are. On the radio, it looks like 0.6 megahertz, okay? That's how you'll see it on the radio. For the 220 band, the 1.25 meter band, it's 1.6 megahertz negative, okay? All the time, that's the standard. On the radio, it looks like 1.6 megahertz. And here's an actual screenshot of one of my radios that is showing you the difference. They call it difference, 1.6, and the direction is a negative, okay? So I have to program the negative and the offset in this radio for it to do what it's supposed to do. And we need to take a look at your radio, okay? Okay, and then of course the 70 centimeter band, it's a 5 megahertz offset, and it looks like 5 megahertz on your radio, okay? And it's always negative.
So that's a subtract.
Yep. 1.6 subtract, 5 megahertz subtract, 600 kilohertz can be plus or minus, and you have to take a look at the actual frequency because it'll tell you if it's a plus or minus, okay? Why they did that, I'm sure there's a reason, but we don't have to know in this class. Just know that you have to verify that it's either plus or minus. Because if you program it to do a negative offset and it's expecting a positive offset, you'll never talk to it. Okay, so then the other thing that we have is the PL tone. The PL tone is sometimes referred to as a privacy tone, and it's used to tell the repeater to repeat the accompanying RFs, okay, the RF signal. Now, without this PL tone, and if the repeater is configured to use the PL tone, the repeater will not repeat the signal, even though the RF frequency is correct. You have to have the PL tone. The PL tone itself is either an analog subaudible tone, so that's something that we could hear. We can hear a 60 hertz. I can't hear 60 hertz anymore, but dogs can hear 60 hertz. It goes to 67 hertz to 254 hertz, or it could use a digital code sequence or a DCS code 23 through 754. Okay, you must set the PL tone in the menu to either transmit or receive or both. Some repeaters require both. So you need to be aware of that. And in the menu, it'll say, it'll have something to do with, receive CTCSS, transmit CTCSS, receive DCS, and transmit DCS. It'll look something like that. You'll know it when you see it. The Mark repeater uses a tone of 103.5 hertz. You set your radio to transmit on 222.36, we already talked about that, and the transmit CTCSS is set to 103.5. Now when you do that, the repeater is set to listen on 222.36. That's the repeater's receive frequency. That's your radio's transmit frequency. And he's listening for the 103.5 hertz tone. Without that tone, you don't get to talk to anybody. The repeater then transmits whatever's coming in on the 222 on its transmit frequency, which is your receive frequency.
It doesn't transmit, does it?
No. It will only transmit a tone if you tell the repeater to transmit the tone, okay?
And there are some repeaters around here that do require both an input and an output tone.
Yes.
I don't have
Can, can I
Say again, Justin?
ask a question?
Yeah.
You can't really require the person with the radio to have a receive tone, because if they don't put it in, they'll still hear it, right? They'll just hear, they may hear
No.
more than they want to, but they'll always hear the repeater. when they have the receive
They'll
tone.
only hear it if they do not set the tone. If they have
Correct.
another tone set, then they will not hear it. The radio will not open squelch.
So I would say the safest is to never put a receive tone, because if you screw it up, you'll never hear anything. And then if you're getting too much other
Right.
unwanted traffic, maybe you could put it in.
And that is why most repeaters do not use a transmit PL tone. It makes it a lot simpler on the people on the ground here, right? Now, one
But
thing that you
again-
can do is you can set the tones to be completely different, okay? So if I wanted to, I could go in and program our repeater to receive 103.5, which is our transmit 103.5, and I can tell the repeater to transmit on 67.8 hertz, whatever that other one is. Or a DCS, even a digital code. I don't have to stick with analog. You can do all kinds of crazy stuff like that. Yes, Jeff?
If the repeater is using either a DCS or a PL tone, but you set for the repeater's transmit, but you do not set the PL tone or DCS on your HT for receive, won't you pick up the signal and hear it anyway?
I think you will.
And that was my exact same question.
Yeah.
Is you could put a tone on the transmit of the repeater and probably nobody would even notice.
Right.
If you have a transmit tone on the repeater, your HT will not open squelch if it doesn't have that tone, so you will not hear it.
That's what I think is
That's why they
we
call them
disagree with.
practice tones.
Well, except with GMRS, and I'm going to test this out. On GMRS, if you do not set the PL tone, you can hear it regardless of what the PL tone is on the transmitter side.
That's my understanding on
it
all
defeats
radios.
that.
If you turn off the receive tone, it will pick up any signal, regardless of what's in it.
That is my understanding, but I'm not willing to bet my job on it.
I mean, I suppose there could be a radio that mandates
Yeah, yeah,
That's
No tone.
on the FRS stuff too.
yeah,
FRS.
yeah. I suspect it's going to be real similar to the GMRS, because we do that all the time. But I'm not willing to bet my job that it works the same way on ham radio. And I'm willing to be corrected on that, because I don't know, so. Okay, okay, so this is why our HTs receive only the receive frequency and not the transmit frequency. Well, our receive frequency is the transmit frequency of the repeater. You kind of have to know both, transmit and receive, for all this to work. Here's something that I don't hear a whole lot. Every repeater has its own characteristic or personality, okay? A couple of things you need to listen to when you're listening to a net, and I've been talking about, actually Russ has an answer for us.
I just typed in, can you receive if you don't have the correct transmit repeater tone? It says, no, you cannot generally receive repeater output if you don't have the correct transmit tone set on your radio. Repeaters often filter incoming signals to prevent unwanted interference, so you only hear the repeater output if your transmitter tone matches the repeater's requirements.
Right.
So it works the same on the repeater and the HT.
But I think what you're reading there is kind of, it's mixing two things. It's mixing what the repeater transmits and what the repeater listens to.
Yeah, I agree with you, Jeff. Something doesn't sound right about that.
Doesn't,
Yeah.
if your radio doesn't know to expect a tone and it receives a tone, I'm not sure what it is.
So-
It can do either way.
So here's a good way to answer this.
It will only, if you want to block out everything but what's coming in with that tone, that's what what sets that up.
Right.
So it's kind of an exclusion filter. It filters everything.
No, we get that. That's why we do it.
On the receive.
Yeah.
I suppose, yes, you would hear everything.
If you're not using
If you're not
the
using the
tone,
tone.
yeah. Will you find out which repeater uses a transmit PL tone?
Yes, I will.
Okay, and I'm going to program that in without a tone and see if my radio receives it. It's a simple troubleshooting technique. It's called try it.
You can do that with two HTs too. I mean,
Yeah, exactly. We'll do that afterwards, okay? Good stuff. Okay, let's get back to the personality of a repeater. So, again, we've been talking about this in the nets. A lot of people, they're not listening to what the repeater is doing, and what do I mean by that? They'll transmit, and as soon as they hit that PTT button, they'll start talking, and what they don't understand is the repeater takes a half a second to sync everything up, okay? And especially if we're talking about repeaters that are tied together, which we'll talk about later on, like on the intertie. It takes a few seconds for them to all sync up, okay? So every repeater, even the Murray Amateur Radio Club's repeater, has its own characteristics. So when you're listening to a net, listen to what the repeater is doing. And if you, every once in a while, you hear somebody eat the first syllable, you know that what you need to do when it's your time to check in, your turn to check in, is to, when you hit the PTT button, click, take a breath, this is N7XTL. And that will give you enough time so that everybody on the air will hear, this is N7XTL, okay? Also, there could be identifying tones for any number of reasons. So listen to the repeater, and listen for its personality and how it reacts. Every repeater is different, okay? They're not all created the same. And here's, oh, and I already talked about this, the repeater has a trick up its sleeve. Even though we're a 40-watt transmitter, because of the height and the gain and the coax that we use, our ERP, or effective radiated power, is 320 watts. That's a beautiful number off of a 35-watt radio, right? It's fun stuff. Okay, now, not all repeaters are created the same. We have what's called a parrot repeater. These repeaters transmit and receive on the same frequency, okay? These are the exception. You're not going to be talking on these very much, okay? It records what it receives and then transmits on the same frequency. And there's a lot of services that use parrot repeaters to listen to how your audio is, for example. Ham radio has a lot of those. Those type of repeaters may use IRLP or Echolink. It might be using any of the digital systems. As a matter of fact, the Bear Link repeater on the Intermountain Intertie used to be this type of repeater, a parrot repeater. It's been since converted to normal repeater use. Now, we talked about linked repeaters. We can also connect repeaters, and that's called linking a repeater. So one transmitter will send and receive and send its signal to another repeater site hundreds of miles away. We use Yagi antennas to focus the beam so that we can hit the long distances. And there's a little bit more information about that. I'm not going to get too far into the weeds on this. This is just a high-level view of linked repeaters. We have 3 linked repeater systems in Utah: the Intermountain that we're always on, the Sinbad network. I use the Sinbad when I am up on my property in Duchesne, and the Cactus Intertie. It's a private repeater, and I've never actually been on it. Then we also have digital repeaters that use DMR system, Yaesu System Fusion, and D-Star. And we also have P25 repeaters. Those are all digital. Then we have the internet-linked repeaters, the IRLP and Echolink. That's all I'm going to talk about that. If you want to get more information on that, you can look at our additional topics there. Just click on that. This presentation will be on the web in a few days, so you can get it there. So we are at the last slide. Does anybody have any preguntas? And incidentally, if you Google, do you have a question? Arabic, that is correct. Hebrew, that is correct. And I already know what Spanish is. But if you know Hebrew, you'll know that says, do you have a question? So, any questions? Okay.
So, I have a question.
Yes.
A dumb one, but I'm going to ask it anyway.
Justin, you better not come back here. I'm going to take my little whip antenna on my HT and whip you.
I'll reschedule my flight long enough that you forgot about all the dumb questions I'm asking. But,
Shoot.
So the parrot repeater, that's what I was wondering, it uses the same frequency. So it's got like a tape recorder in it or something, and it just literally...
It's a digital recorder, yeah.
Like, how do you talk on that? Like, you kind of have to expect that there's going to be a long delay in between.
I've used parrot repeaters in some of my digital work, and there's not much of a delay. There is a delay, but the whole idea is to hear what you just transmitted. So I think it requires the entire, and correct me if I'm wrong, anybody, but it requires you to complete the transmission, to release the PTT before it will retransmit that on the same frequency.
I would think it would have to. So then the
Yeah.
person you're talking to has got to just basically sit there for 10 seconds while you talk and assume that you're talking.
Yep.
Like you got to have a good protocol, I guess. Otherwise, you're going to be totally talking over the top of each other.
These parrot repeaters aren't the repeaters that we'll be using on a day-to-day basis. They're specialty repeaters. So,
Yeah, it sounds like it would be much harder than normal to use.
yep.
Okay, well, interesting.
And that wasn't a dumb question.
I guess it wasn't that dumb. I was just curious. I kind of remember reading about it, just curious what they did, but that is kind of interesting.
Yep, cool. Anybody else have anything? Yes, Jeff?
Are the LEO satellites parrot repeaters?
I'm sorry?
The LEO satellites, are they?
Yes, yeah. So low Earth orbit repeater, satellites, they can be parrot repeaters. Absolutely. There's also repeaters on the ISS ship. There's also repeaters that are individual repeater satellites. You just have to know when to go through there, so.
This just did.
Okay, okay, so Russ gave me a page of frequency repeaters that have different PL tones.
That's the access tone, yep, up and down.
Okay, thanks. I'll play with this later on. Did anybody else have any questions before I stop the recording? Yes?
Looking in the repeater book, I don't see no repeater book.
Which repeater book? Oh, did you add the 1.25 band? It should be listed because
You have to go into something up there. Yeah.
you see it? And it's not there? Because they get their information from, I mean, that one slide that had the blue and white, that was just the regular,
Well, see, he's looking at the app and I'm looking online, and it's online.
yeah,
It's there.
yeah, who knows? I'm gonna talk to my congressman. So, okay, I'm sorry?
Will it do any good?
Nope, but it'll make me feel better. Okay, I'm gonna stop recording. Thanks, everybody, for joining, and we'll see you next time. Yeah, I
Thanks, see you
tried
later.
one to stop recording in the